So, hello everybody. We are happy for giving this talk for you guys, the Belarus Ruby on Rails user group. And we will be covering the main concept of the Cloud Foundry, how you can do to install it and start hacking on it. The first thing that I want to say is that this talk was named how we build our own Heroku using Cloud Foundry, but we decided to change it by why Heroku can't sleep at night. So let's start introducing ourselves. I'm Gaston Ramos. I'm using Ruby since 2006. I'm from Santa Fe, Argentina. I work in Altoros, and I done some open source contributions to Rails, Debian, and Ruby News, and Cloud Foundry.
So, hello, my name is Alan. I've been using Ruby since 2007. I'm also from Argentina, from Buenos Aires, and I work at Altoros too. I have some contributions on projects such as Building and Cloud Foundry. Before starting, we would like to do some disclaimers. We are not yet Cloud Foundry experts at the moment. We only have a couple of months working with Cloud Foundry. Something else that we'd like to point out is that we'll cover this talk for the Cloud Foundry version 2. Cloud Foundry version 2 is actually under heavy development, and it's like changing every day, so it's quite an estate. So well, let's start by explaining a bit this concept of Cloud Foundry. Cloud Foundry is vast. It's an open source project and is available for a variety of private cloud distributions and public cloud instances. So then, what's a bus? Well, a bus is a category of cloud computer services, right? It facilitates the development of applications. We can give some examples such as Heroku or Engine Jar. Right now, version 2 of Cloud Foundry support bitpacks. Bitpacks are packages developed mainly by Heroku, and they contain the logic to stage and start applications of a defined language. So, in case there are no bitpacks that support the language you want, you can easily implement one for Cloud Foundry. So, why Cloud Foundry matters to hackers? Well, mainly it matters to us because it's open source, so we can modify it as much as we want. In fact, we are doing it. At the same time, Cloud Foundry is well designed, so it's nice to work on it. The third thing that we would like to mention is that Cloud Foundry has no bundle locking. This means that if you move from one pass to another that supports Cloud Foundry, you will be able to migrate your application quite easily. Cloud Foundry tries to respect some architectural goals. It has no single point of failure. It also has a distributed state. And it has a self-healing process where instance can be rerun and restart by itself. And it's horizontal scale. Shows you like the minimal amount of components that you need for Cloud Foundry. As you see, it's quite a big system, even when it's like small. So we won't get deeper in the interaction between components. But we would like to talk a bit of the responsibility of the most important of them.
Okay, thanks, Alan. One important thing to say is that all the components are written in Ruby. So let's start one by one. The main thing that I want to say is that all the Cloud Foundry components communicate through NATs. And what is NATs? NAT is a very, very simple published scrap messaging system. So the next one is the Cloud Controller. The Cloud Controller is a REST API with endpoints for clients. That means, for example, when you are pushing an application to the Cloud Foundry platform, The main component that it will be attending that request is the cloud controller. It also maintains a database with table for user information, like organizations and spaces. The next main component is the DEA, the Droplet Execution Agent, and it takes care of managing an application instance life cycle. It also can be instructed by the cloud controller to start and stop application instances. It keeps track of all started up instances and periodically broadcasts messages about their states over NAS. Well, this picture is showing what's happened when you push an app to Cloud Foundry. You don't need to have a deeper understanding of that, but the point is to have an idea how it works. So the question is, how can we get all the Cloud Foundry components up and running to develop on it? When we started on this project, there was no way to set up a Cloud Foundry environment easily. So we made it. How we made it? We did a Vagrant installer. We put the whole environment inside a Vagrant VM with some chef recipes and raised tasks, and we will show you some of them. So this is the repo, and the repo is at GitHub. So you should go there and clone it. After that, you should run some commands. The first one is rake host bootstrap. After that, you will be able to start up the Vagrant machine. You should log in into them via secure shell with Vagrant SSH command. And after that, you should go to the Vagrant folder inside the Vagrant machine. And after that, you should run the command rake cf bootstrap. This command will take about 30 minutes to be done. It will install all the required dependencies like shems and libraries. And after that, you will be able to start up the Cloud Foundry itself with the command forman start.
Okay, so we built this mainly to have a tool to develop with Cloud Foundry. Let's say make it easier for newcomers of this open source project to hack on the project and get involved. I hope this talk is about to finish, so I hope we make some interest in you about this project, so you can get a deeper look into this project that is mainly followed by VMware and the guys from Pivotal Labs here in San Francisco. Now we will give some time for any type of question that you can think of related to Cloud Foundry and this talk.
Okay guys, just let me ask
Sergey, are you there?